Wave-particle duality is a fundamental concept in quantum mechanics that describes the behavior of subatomic particles, such as electrons and photons, as both wave-like and particle-like. This concept has been experimentally verified and is considered one of the cornerstones of quantum mechanics. Hello viewer, welcome back to another video. In this video, we explore the concept of wave-particle duality in quantum mechanics and its significance in our understanding of the subatomic world. Understanding wave-particle duality. The wave-like properties of subatomic particles, such as wavelength and frequency, can be described through the mathematical formalism of wavefunctions. On the other hand, the particle-like properties of these particles, such as position and momentum, can be described by quantum states. The nature of subatomic particles cannot be determined until they are measured or observed due to the fundamental uncertainty principle in quantum mechanics. This principle states that the position and momentum of a particle cannot both be precisely known at the same time. Implications of wave-particle duality. Wave-particle duality has significant implications for our understanding of the subatomic world and has been used to explain phenomena such as interference patterns, quantum entanglement, and quantum tunneling. Interference patterns. Interference patterns occur when two or more waves intersect and combine to create a new wave pattern. In the context of wave-particle duality, this phenomenon can be explained by treating subatomic particles as waves. When two or more waves intersect, the peaks and troughs of the waves can either reinforce or cancel each other out, creating an interference pattern. Quantum entanglement. Quantum entanglement is a phenomenon where two or more subatomic particles become entangled, meaning that their quantum states become correlated in such a way that the state of one particle cannot be described independently of the other. This phenomenon can be explained by treating subatomic particles as both waves and particles. When two particles are entangled, the wave function describing their combined quantum state spans over both particles, creating a correlation between them. Quantum tunneling. Quantum tunneling is a phenomenon where a particle can pass through a potential barrier even though it does not have enough energy to overcome the barrier classically. This phenomenon can be explained by treating subatomic particles as waves. When a particle is described as a wave, it can extend beyond the potential barrier, allowing it to tunnel through the barrier. Wave-particle duality is a fascinating concept in quantum mechanics that has significant implications for our understanding of the subatomic world. This duality has been experimentally verified, and has been used to explain various phenomena such as interference patterns, quantum entanglement, and quantum tunneling. The concept of wave-particle duality continues to challenge our understanding of the nature of reality, and provides a glimpse into the strange and mysterious world of the subatomic realm. Please follow us on social, and don't forget to like it and subscribe to our YouTube channel. See you soon.